Okay, so the space game. Very exciting space game. Uh, and actually, all things considered, it's actually not that bad. But because there's a number of conflicting um, goals that we have in mind here. So, um, and I'm gonna mute this. So this is what I'm gonna give you. I'm gonna give you all the code for this, and um, let me bring up my window again. Okay. And so this is what it looks like, and it has keyboard controls. You could do something different. You can do anything different with this that you want. The only requirement on this is that it uses Canvas. Um, uh, you shouldn't use extra libraries other than the code that I gave you. You should try to program your own stuff. Um, and all the other same rules of programming that we've done so far apply. So you can use any of the code that I've given you for anything. Um, Anything else you should create on your own. So images you create, you should have the rights to. So they should either be free and clear, or you should give credit for them if they're usable with credit, or you should make your own. So anyway, I'm controlling the blue ship with the keyboard. I can press the arrow keys to move this around. I can press two keys at once. So if I press the down and right, it moves down and to the right. If I hit the edges of the screen, it stops me. So I'm holding down the right arrow key right now. It won't allow me to go beyond. Oh, share my screen. Thank you. Uh, Sorry. I just got off another call where I was sharing my screen. So forgot to reshare it. Thank you for that. I am recording this, so that part was on the recording. Take it from the top. This is the space game. We have the pink ship is the enemy ship, and the blue ship is the player ship. And the controls that are built in on what the code I'm giving you are keyboard. So again, I'm using the arrow keys and the keyboard. So I'm pressing right to move right, left to move left. If I hold the right key down and I go beyond the boundaries of the screen, it won't allow me to go off the edge. The program also won't allow the enemy to go off the edge, and its movement is somewhat sporadic, as you can see, but it's randomly generated. So we're using some random numbers in there. And it also allows me to resize the screen here. So if I resize the screen, it still won't allow me to go off the edge. So if you have a keyboard connected to a phone and it has arrow keys that are usable on it, you should be able to play this on a phone, as long as it detects the arrow keys. So any device that has arrow keys, this should work on. So that's kind of the game. The other thing is if I hit escape, it'll pause. So none of the other keys are activated. None of the ships move. The universe freezes. If you notice, the universe might not show up on the screen share too well, but the universe is sort of parallax moving in the background. And the score will update when my bullet traverses the enemy ship. So if I'm going to get close to the enemy ship so that I score a little bit, okay. And as my bullet passes over the enemy ship, I gather up points. And you don't have to implement yours that way. In fact, you shouldn't, because you should have a winning condition. I don't have any winning condition on this, so mine just plays forever, just incrementing points or not into eternity. So you should have some kind of a winning condition on yours. So, any questions so far? I probably missed something, but I'm going to dig into the code otherwise. You guys seem to get this stuff so quick, so I don't want to bore you. Looks cool. Thank you. It's it is what it is. Can you use an alert to reset the game for your win condition? You can do absolutely whatever you want as long as you program it yourself, and it makes sense, right? So if I open up your game and I play it and it makes sense, you're good to go. So alerts are tricky though because alerts are somewhat asynchronous. So you have to be careful because sometimes an alert can happen before the code that executes after it. Okay, or that executes. An alert can happen sometimes before the code that's listed before it. Okay, so you have to be a little bit careful with alerts. Okay, so. But otherwise, an alert is fine. So if you want to change the graphics and if a minimum viable B grade on this would be to maybe just count it as one hit every time you hit the ship and count up to 10 hits, or have a time limit, and then have an alert pop up and then allow you to reset the game. If you and change the graphics out, right? So if you do something like that, you'd be good for a B. You'd be good for like 8 out of 10. So if you do something like that, you'd be kind of good to go. What is that? Okay, so any other questions on that? Otherwise, I'm going to jump into the code. Some of the code's a little bit confusing, but hopefully it's encapsulated well. Thank you for saying no. All right, let's just move this out of the way for now. All right, so I'm going to jump around a little bit, sort of inevitable. So let's start with the HTML. Collapse this for right now. So the HTML is the easiest of all. Okay, so the simplest of all HTML, probably the simplest you'll ever see in an HTML document. Even simpler than like our hello world was, right? So we have a div for pause, and this technically doesn't even need to be there. You could generate this in JavaScript, right? But I did this just to make it visible, and it was easier to just have this and have class hidden on here. And then a div for the universe. So the universe has that background, the space background. And then we have canvas. So this is going to be using HTML canvas. Okay. And let me just... So if you are playing along at home on W3 Schools, if you just Google HTML Canvas and click on the W3 Schools link under HTML Graphics, HTML Canvas, there's actually a great page on W3 Schools about HTML Canvas. Okay. A canvas is a rectangular area on an HTML page. In our case, it's going to take up the entire page. Okay, but it doesn't have to be. So this area here, this 200 by 100 pixel area could be a canvas. You can draw onto the canvas. You can draw literal lines using JavaScript. So you can draw graphics. So lines, circles. You can draw text. You can draw stroked text, which is an outline. So you can have like white text with a black stroke around it. If you're familiar with Photoshop, you can have red text with the white stroke around it. Things like that to allow it to stand out on backgrounds. Uh, we can draw gradients of different kinds, and we can draw images. So we're going to use a few of these. We're going to use out of the box what I'm using. You can use all of them if you want to, and there are other properties that aren't listed on this page too. But we're going to utilize the text, and we're going to utilize images, and we're going to draw a rectangle. So if we go back to our space game, you'll see that we have a white rectangle here. So we're drawing a rectangle. The whole page is canvas. So we have the canvas over the top of our universe. So the universe is the background image, and we have some JavaScript to cause that to move. And then we have our score is text within the canvas. So that's drawn text. So it's not HTML text that we can select. So I'm trying to click on this and select it right now. It's not actual text that can be selected. Okay. So Canvas is one way you could generate text that's not selectable. If you had a reason to do that kind of thing. And then we have our ships and our bullet. Those three elements are all images that are drawn onto the canvas. Okay, so that is that. Any questions about Canvas so far? You guys are too smart. It bothers me. I'm already gonna need more coffee. You guys already have this down. So, all right. So let's jump into our CSS. Our CSS is similarly pretty simple. Okay. So not only are we not including Bootstrap or anything else, so there's no other CSS to deal with that you have to even worry about. We have relatively simple CSS here. Okay. So I'm giving you all this, so you don't have to really memorize any of this. So body overflow hidden. This is meant so that you don't end up getting horizontal scroll bars. Okay, so because of rounding errors on the way things can work, different browsers you could end up with an overflow condition, and you could accidentally end up with some scroll bars when you resize the screen. We don't want that to ever happen. So that's what this is about. Okay, so this is just kind of a fix for just some browser bugs almost if you're resizing. Okay, so that's all that does. The universe, nothing really special here. Same thing. We want to have overflow hidden, so there's no scroll bars within the universe. A div could end up with scroll bars too. Position absolute. We haven't really talked about position absolute too much. I think we did a little bit with the hello world, but basically I'm making this fill the entire page. So it's 100% wide. It's 100 screen units tall. So that just means 100. It fills the entire space completely. Then we're giving it the space background, that JPEG, giving it absolute position. And starting from the top left, so it fills the entire thing. Background size is 100%. Background position is 0, 0. So all these things are just to make sure all that stuff is set so that it fills the entire thing. And we do this basically the same thing with pause, except we're using the pause image. And if I go into images and I pull up pause, it's this big, and I'm making it fill the whole screen, and we can do that with a background image by using the contain property. So background size contain, so it grows to fill the whole screen. And so I'm having it be a white background, which is the same color as the background of the pause. So it's white, and then I throw the pause over the top of that, and I center it. So if you recall, when I hit the pause, if I hit the escape key, that's what that does. Okay, and so it will resize no matter what dimensions this is. It'll do the right thing. So it won't distort this, but it will grow as necessary. So that's how I accomplish that. And then Z index 1, that allows the pause to float over the top of the background. Okay, so I'm making sure that it's on top of everything else. And finally, opacity 0.5. I just made this semi-transparent so you can see behind it that there's ships and stuff. Okay. Any questions at all on the CSS? Want me to try changing any properties so you can see what anything looks like? Not too much new here, if anything. You guys are good, I think. So, but we can circle back to that. So I'll keep moving. So now into the JavaScript. So same structure that I've been following for everything else. We have some constants to start off. So these are in the newest versions of JavaScript. We can have constants, and again, constants are just variables that don't change. We use constants for, this is a great purpose for a constant. Here I'm setting up a more easily memorable name for a number that isn't easily memorable. So we have these key codes that are used in JavaScript for each of the keys on the keyboard. So the escape key is number 27. So rather than have to remember that, I'm using escape key code to equal 27. So wherever I wanted to use that number 27, I would just throw in escape key code. And space is 32, right arrow is 39, and so forth. Okay, so a perfect use for constants is whenever you have some kind of a numeric, especially if they don't make any sense. You know, if they're sort of arbitrary and you want to make it more understandable. Makes your code a lot more clear. Because otherwise I would have these numbers sprinkled throughout the code, and you'd have to put comments there to explain that, which is also fine. But this is, it's better if your code is just self-documenting. And then I have some Boolean values here. These are, I'm setting the conditions for each of the arrow keys. So, and the reason for that is I want to be able to have multiple keys pressed at the same time. So I'm setting them as Boolean so I can see if I check to see if they're true and false, rather than, because I'm only going to get the key codes one at a time. So I'm setting them to true or false, and after I check them, and then I apply the movement. So this allows me to have, I can move diagonally up and to the right. So I'll demonstrate that below. And then we have some global functions. So get random int, because I'm using that random movement for the movement of the enemy ship. I wanted to kind of encapsulate that in its own function. I give it a minimum value and a maximum value, and then I just have it generate the random numbers. So that's the formula for generating that, a number between min and max. And then we just have our regular by ID function that we've used before. Okay. Any questions on any of that? Please interrupt me if there is anything, so that I don't feel like I lost the call. Even if it's a super stupid question, that would be actually amazing. I had really great questions yesterday. So if you guys don't have any questions, I'll be actually a little bit disappointed. So you can move diagonally. Yes, you can. Yes. See, that is an excellent question. Yeah, it is pretty cool. Yeah. In the first incarnation of this, I did not have that set up because I actually thought that would be, because I try to keep this simple, because like I always say, none of us were born knowing JavaScript, and none of us were born, knowing programming and algorithms and any of that. So I'm really trying hard to introduce some relatively complex ideas, but in a friendly kind of way, a simple, approachable kind of way, as best as I can. And you guys are kicking butt at it, so hopefully that's working out okay. All right, so we have a few objects that we're creating here. So we have ship, bullet, and game. So I'm going to jump down to the bottom. So this is where, so unlike the, so some of the programs, I move back and forth a little bit because I have, there's different ways of implementing object-oriented programming, and so this is, I'm kind of, these are global. I'm utilizing some global variables instead of putting everything into the objects. So I'm creating a game. So let game equals game here. So a couple things that I'm doing here. So I'm in order to utilize the canvas, we have to initialize the context of the context. We have to initialize the context of the canvas. Okay, so we do that by doing this. Okay, so we grab the game board by ID, and then we do get context 2D. Okay, so yeah, there are 3D canvas things that you can work with too. And I'm assigning that to G context. So then down below, I'm using G context for the things that I'm writing to the context. I don't know if it's my Wi-Fi or you, but you keep cutting out. I don't know. Depends if I'm cutting out for anybody else. I'm recording it though, so hopefully that it's just you. Okay. Well, that sucks. Sorry about that. Oh, it's not just her. Well, I'll try to repeat things and go slowly too. Um, Hopefully that'll help a little bit. All right. So, and if anything does drop out, ask me to repeat it. No problem with that. So, all right. So, kind of going forward. So, like I said, I'm grabbing the context here. Okay, thanks for that. Screen share is just a little laggy. So I'm grabbing the width, the height. So just some setup stuff here. I'm creating the new game, and then I'm kind of implementing the game here. Okay, so there's some setup stuff when I call game. We'll see that in a bit. But then I'm checking resize to start with. Okay, so which is going to kind of do some of this stuff. It's going to resize the canvas and the universe and everything. I'm calling check keys. I'm calling release keys. We're going to look at those. And then these are the things that are called repeatedly. So I'm setting up this. So this is kind of the game loop. Okay, so two things are run repeatedly. So set interval move background. This is set to run every 10 milliseconds it moves the background. Okay, so that's the speed at which it moves the background. So if I lower this, it'll move the background faster. If I increase this, it'll move it slower. So this is the number of milliseconds at which this function is called. Okay, so it calls this function every this number of milliseconds. Okay, and the lowest number it can really go is 1. So or technically 0, I think. But so then gameplay, we're trying to call that as often as possible. What dictates milliseconds versus seconds? The whoever created this function. So set interval, whoever created this decided that this was going to be an integer value and it would be milliseconds. And it's milliseconds because computers can go faster than seconds. So, and a millisecond is one thousandth of a second. So if you want it to go every second, that's 1,000 milliseconds. Just in case anybody was fuzzy on that. So I don't know if that answers that. So is set interval always in milliseconds by default? It's always in milliseconds. There's no default. It's always in milliseconds. It's never in seconds. Yeah. So if you wanted it in seconds, you'd have to do that conversion yourself. Yeah. Good. Excellent question. Yeah. Which is confusing because humans don't think in milliseconds really ever. Even when you're thinking in milliseconds, you're kind of implicitly doing that conversion because, even that word milliseconds is a fractional unit, right? So it's a little weird. So anyway, all the action happens in play. So this is the thing that happens over and over again. So keep that in mind. Anything that has to happen repeatedly is going to be happening in play. So a lot of these other things get called again from play. So let's go way back up to the top, and I'm going to look at ship, bullet, and game. Yeah, let's do that. So let's look at ship first. Okay, so now because this is we're utilizing object-oriented principles here, and we could have taken this a step further. There's a balance here, though. So, and I'll explain myself. So when I create a ship, I'm taking in an image file. Okay, and when I call these down below in game, I'm passing in either enemy or player, and it will generate a ship with that image. Now it doesn't know, ship doesn't know whether it's an enemy or player based on that image, but it will generate that as the image for it. Okay, so game still has to keep track of whether it's a player or an enemy, but there is functionality in here that can be called one way or the other. So it's not ideally object oriented, but this is a pretty simple program. So we could have abstracted out some of that logic into some subclasses, so to speak. But I didn't want to make this overcomplicated as an object oriented exercise, but just to kind of set the stage, that is something that that you might be doing, later on in object oriented classes. So anyway, so here I'm grabbing the left and the top coordinates of the screen. I'm setting the width and the height of the actual image. So if you pick a different graphic to use, which you should, you're going to need to change these numbers here to reflect those images. And if you want to have different sized images for the player and the enemy, you're going to need to probably pass these numbers in as parameters so that you can set those dynamically. Okay, so keep that in mind, because if they're different, you need to convey that to the object somehow. Okay, so just think about that if you're gonna make that change. Not hard, but that's something you'll have to think about. And then we just create an image. Okay, so we're setting up our values, our variables that are going to be used in ship. Okay, so these are our ship properties. So the left and top, where does the player spawn when the game starts? Excellent question. I will totally get to that. Yep. All right, so then I just have some accessors and everything. One thing is image source after it's created. So once image is created, source is set to image file. So we set the source of that to image file. So these are just accessors. These could probably be deleted because I don't think I'm, for the most part, using them. The first thing that is a new function is boundary check. And all this does is checks to see if you're moving beyond the boundaries of the screen. So if left is less than 0, keep left at 0. Pretty easy, right? So if I'm holding down the left arrow key and I'm moving where left would become negative, so the leftmost position is 0, and the topmost position is 0, and the the rightmost position is, so we have to take into account the width of the, when we're dealing with the bottom and the right, we have to take into account the size of the ship. Okay, so we have to add the width and the height when we're checking the right and the bottom. So I'm adding left, which is the current position. Okay, so it's a little confusing, but left, we're measuring from like the left hand pixel point and the top pixel point, and we're adding the height and the width. Okay, so we're kind of moving the point of that. So so as long as this is, so if this is greater than client height, so if this is greater than the screen, so if it moves even 1 pixel beyond that, then we reset top to be client height minus height. So we reset it so that it's not, so that it doesn't go beyond that. Okay. So this looks a little bit complicated, but basically we just don't let it go beyond the width there. And you don't have to understand this entire thing, but that's basically the gist of it. So left and top are easy. Bottom and right, we have to take into account the width of the player or the enemy. Okay, or the player or the enemy for the most part. So navigate. So this is where the player, not the enemy, we are passing in the keys that are pressed. So we're passing in which keys are pressed here. So this is a switch statement, which is kind of like just a differently organized if statement. So we're saying if the key is equal to right arrow code, then say that this is pressed, and we only allow one thing to be tested at a time because it can only check one key press, and this is where we're setting the value of we're setting this to be pressed or not. Okay, so we're setting this to be true or false based on this situation. So so this is part of what allows us to have like the up and to the right and down and to the right and so forth to happen here. Okay, so and I guess I was jumping ahead, so sorry, I was stammering there. I don't think I have to do boundary check here because we're not actually changing the position here. So I don't think it hurts to have this here, but I don't think this needs to be here. So sorry if that's confusing. So I might want to take that out. It does need to be here. Okay. So in move ship, this is where if the right key is down, so here's where we set them to be down or not. And here we checked, we're not saying if else if, we're saying if. So you can have multiple keys down at the same time. Okay. So I can have right, I could have technically right and left held down, but they would cancel each other out. But I can have right and up pressed at the same time. So I would be subtracting from top, and I would be adding to left at the same time. Okay, so those two functions kind of work in tandem that way. And then we're calling boundary check because we just changed those pixel values. So if this would go off the top of the screen, or off the bottom of the screen, I guess, it would readjust that right away. Move random is very similar to move ship. Move ship bases it on key presses. Move random does the same thing, but bases it on random numbers, and this is for the enemy ship. Okay, and this is something that could be done better than what I did. Okay, so it's generating random numbers between 0 and 2 to determine which direction it's going to travel. So it's going to move left and up, or left and down, or right and down. So it's going to figure those out. So this is kind of the direction. So it's getting a number between 1 and 2, or between 0 and 1. And then it's just doing it's converting it to Boolean. So it's figuring out a true false. This is kind of a method of generating a Boolean value. It's going to generate a random true false value here. Okay. And so here I'm saying if I'm moving left, then move it left between a randomly generated number of pixels, and otherwise move it right, a randomly generated number of pixels. Okay. And same thing with top. Okay. And so that is it for ship. Okay. So I'm going to jump down to, you said, where does the player spawn when the game starts? So that is in game. Okay. So player ship. Okay. We're creating player, enemy, bullet. Okay. And there's a couple other global variables here that I'm going to global to game. So some properties for game. So points, whether the game is paused, there's a Boolean there. So then display points, move background, clear objects. Where did I put that? Is that in ship? Oh, I'm sorry. Yeah. So the where does the player spawn when the game starts? Sorry, it's at the top of ship. I thought I called that in from game. So so this picks the actual starting position of the ship, whether it's the enemy or the player. Yeah. So this gets the a random number from 0 to the width of the board. Okay. Now, technically, as we already saw, this number, because of the size of the ship, could go off the edge of the screen, but it'll fix it down below right away. So this is actually fine. Okay. Like we probably could move this down here and adjust the width and height, and it'd probably be better, but it ends up being fine. Okay. So yeah, so if we so it is random. So if we unpause this and I just refresh the screen, enemy, player, refresh the screen, player, enemies over here this time, refresh the screen. So every time they're just completely random. Okay. All right. So guess I didn't need to jump down to game yet. So, all right, let's keep going on bullet. Try not to be too boring. So bullet is very much like the ship. Almost identical, in fact, because we're passing in the image file. So same kinds of things apply, the left and top, the width and height. So when I was creating this, I copied and pasted it. Boom. Okay, so I'm like, this is a fine starting point. Let's go from there. Okay, so all of this stuff is all identical. It's called Space Game, but can you change the spaceship's background to something else to make it unique? For sure. And you do not have to call it Space Game. You can call it whatever you want. In fact, you can call most of the projects anything you want. Just make sure that it's clear what project that's for. Then, in the menu on your server. Okay. Great question. Okay. So these are 36 by 36. So this is a round thing. All of these are PNGs, by the way. So if you do create your own images, notice that they're transparent backgrounds. And you're going to want to make sure that they mostly fill the space. Okay, so you want to make sure that there's not a lot of transparent space on these. Same thing with the bullet. So a circle is probably okay. You want to make sure to not have a lot of like maybe I don't know. Circle is probably, I don't know. I can't think of a shape that would be. What you just don't want to do is you want to keep away from circumstances where this is going to hit the enemy, and because it's going to count as a hit even when it hits these invisible parts because it's a square. These are rectangles. So when the invisible part here touches the invisible part here, that's going to register as a hit. Okay, without some complicated like subtraction. So, and you can factor some of that in, or you can say it has to register X number of hit points. So there's some logic you could try to build into it to handle that. So just keep those things in mind. All right. So the only other thing that's kind of going on in here is visible. So the bullet always exists, but it's not always visible. Okay. So there's always a bullet in the object hierarchy, but it's not always marked as visible. So and then the direction. So when it starts, it has no direction. It's not going anywhere. Okay. So here we create we give it the source of the image. And all right, so then boundary check. This works exactly the same way. Okay, except I'm checking to see that not checking. I'm setting visible to false. So if it hits the edge of the screen, rather than set it equal to this number, I actually don't even need to change this. I just need to set it to false, right? So I could actually take these out. Okay. I guess I just kind of wanted to leave those in to show that this was based on that. Okay. But this doesn't need to change. The thing that needs to change is the visible equals false. Okay. Because we want to make it invisible right away. All right. So set direction is where I set whether the bullet moves up, left, down, or right. Okay. And this could be more sophisticated. So the bullets always move at right angles to the ship. So they never move diagonally or curved or anything like that. So you could definitely do something more sophisticated than this. So all I'm doing is I'm checking where the enemy. So these are the player and the enemy coordinates. Okay. So I'm just checking the distances of these, and I'm just checking if it's closer in the X direction than the Y direction, then I blast it off one way versus the other. That's it. And if it's higher than lower, then I shoot it up versus down. Okay, so this looks really complicated. Just doing some simple comparisons. Okay. So one thing here, I'm doing the absolute value function just to so that I can compare these numbers, the absolute value of D and X, just so I can know the delta of those, like how big those numbers are. So one might be negative, one might be positive, but the it could be really close here, but really far this way. So I'm going to want to shoot the bullet this way. Something like that. Whatever. I don't know. Or not shoot the bullet this way. I don't know. You probably couldn't see that on the screen anyway. Okay. So then we have shoot, which takes the keys that are pressed. So we want to check to see if the space key was pressed. And then the player and the enemy coordinates. And so we are, this is where we actually shoot the bullet and we set the direction of the bullet. So we call set direction from within here. Okay. And we also call, there's a little sound effect that plays, a little MP3 that can play. So, and we're always checking to see, when we're dealing with the bullet, we're always checking to see if it's visible or not. And So move, this is again in relation to the bullet, moving the bullet. I'm setting the rate here to 2. So I'm just incrementing the left or top value by that rate, going in the proper direction. So that's bullet. Pretty, I think it's relatively easy to follow once you look at it all together. So I'm going to collapse that now. Now we can look at, what does that triple equal sign mean? If you recall, triple equals is a comparison in JavaScript. In Java, we would use double equals. C++, we use double equals. C, we use double equals. In JavaScript, they screwed up the double equals. So there is a double equals operator, but sometimes this will not be true when it's supposed to be true. So they fixed it and created a triple equal. But they had to leave the bug in there because of old code. So you should always use triple equal. This is why some people hate JavaScript. But just always use triple equals in JavaScript. Yeah, the LOL is appropriate. Yes. But it's it's just one of those things that gives it its own unique flavor, right? So try to appreciate the differences. And while that is a little bit funny, it in a way it helps keep things from being confusing because you can tell at a quicker glance that this is not some other language because that is unique to JavaScript. Whereas when you see Java and C++ side by side, oftentimes they look similar enough that you can be confused as to what language you're even looking at. And you can make some mistakes based on having more experience with one language over the other. Or C Sharp, that falls into that category too, where those 3 languages are so similar among themselves. So, excellent question. All right. And then game. So I kind of started on this one. We have total points, whether the game is paused or not. And then we're creating the player ship, enemy ship, bullet. So, and then we have our game methods here. So I have a method to display the points. And so every time we're displaying the points, and this is called every second, okay? Or every millisecond, I should say. As long as the computer can keep up, right? So there are limits where it might not be called once every millisecond, but it's basically as fast as it can. So it clears the rectangle. So it deletes the rectangle that's there, which will it'll delete it so that there's nothing there. So it'll be wiped out. And then we fill it with white. We create a white rectangle over the top of it, over the nothing. And then we set a 30 pixel Arial font. You can certainly change the font, but you'll have to have that font on your system. So you have a kind of a limited range of fonts on there. Okay. And this sets the font color to black, and then this is what we actually print out. And these are the coordinates in that box. The coordinates on the screen, I should say, of where we want to print this. So 10, 50. Okay. So if we just look at this. So we're 50 from the top and 10 over from the left. Okay. Oops. And so it's solid text. It's fill text. Okay. So it's not the stroke text. So just solid black text. Okay. So that gets updated every time we call this, which is once every millisecond. This is move background. So again, if the game is not paused, then we execute all this stuff, which is move the universe. Okay. So we grab the universe, and if you recall, that's the div that it contains the canvas. So it's the outside div that contains the canvas. And then this is actually a little bit weird and complicated. and I had to actually look this up to know how to do this, to make this work the way that I wanted to. So um, you have to grab the computed style of the, so you pass BG into computed style. So this is a little bit different than some of the other properties we have normally gotten. So I want to I'm grabbing the computed style, and then I'm out of the computed style. I'm getting a specific property, background position X, and I have raw X, and I have to grab just the integer portion of position X of the raw X. Okay, uh, and I have, so basically I have to get rid of the pixels off of that. Okay, so that we can do some math on it. So all I want to do is just get rid of the number one. Okay, and I'm gonna just leave y alone, but I did the operation on y just in case we wanted to, if you wanted to move both of them, if you wanted to move it diagonally or something, you can do that. Okay, so I'm grabbing y and x just so you can do that. Then I have to create a new position as a string. So it's generated as integer mashed up against px space y as an integer px. Okay, so and then we have to pass that back to style that background position. So it's a little complex, but I mean, once you have it, you have it. So this would be something that in the past I would have used jQuery for, so I didn't actually know how to do it in regular JavaScript before. So jQuery is a library that is frequently used for making certain things in JavaScript a little bit easier. So it's not super hard, but it's a little bit weird. So it's not the normal way of doing things in JavaScript, but totally doable. So then, again, once every millisecond, we are clearing the object. So just like we cleared the score, we have to clear all of our objects. So we have to clear the player, the enemy, and the bullet. Okay, and I'm checking to see if the bullet is indeed visible, but otherwise we just clear the bullet. And then after we clear it, we draw them. So we draw the player, the enemy, and if the bullet is visible, the bullet. So we have to, every millisecond, it's redrawing those. So you're handling that. So as opposed to just moving elements on the screen where you just give it a new position and it just moves, or you hide it and it just disappears and you just flip it on and off, you have to control all of this functionality in Canvas. Okay, so there are pros and cons to both approaches, but you have to actually take control of some of these things. And then check keys. So we're checking for the escape key, and this is where we implement the pausing. So all I'm doing is I'm hiding the pause image or not, and I'm setting game pause to true or false so that it stops everything. And if the game is not paused, then I'm clearing the objects, I'm calling navigate, I'm calling shoot, I'm displaying the points, I'm drawing the objects. Release keys is kind of a weird thing because this is sort of a check keys situation. So it's calling this is setting up the event listener key up. So this kind of runs in the background. So this is called down below once at the beginning. So this is saying if the game is not paused, clear the objects, navigate the player ship, display points, draw objects. So the main thing is this is what allows us to move the ship. Okay, so we're checking the keys and we're calling navigate, basically. And check resize. This is what allows us to resize the window. Nothing super complicated here. So we're resizing the height of the canvas and the universe. No big deal there. That stuff's all set really in CSS. but we have to change the placement of the player, enemy, and bullet if they get impacted by that resize. Okay. Then this looks complicated. It's really not. Collisions is if the game is not paused and the bullet is visible, then we have to do this check. And this is a check of the bullet and the enemy. So here we have to check we get the stats on the bullet, we get the stats on the enemy, and then we just compare them. Okay, so this is where we're comparing to see if they overlap at all. Okay, so that's what this does. We're just checking to see if they overlap at all. So we're just doing some math and just checking to see if they overlap. And if they do, we return. If they overlap, we return true, and if they don't, we return false. I think, right? Yeah. So if it collides, we return true. Otherwise, we return false. And then play, if you recall, this is the thing that runs every millisecond. So this should be the last thing here. So again, we call clear objects. We call player move ship. We call enemy move random. We call bullet move, and we're always passing in whether game is paused or not. Passing in game paused. Display points, draw objects. So we cleared the objects, if you recall, and then we're going to redraw them after we get the new information. And then we're checking to see if anything crashed. Okay, so if anything crashed, this is where I'm incrementing the score. So you could do some different logic here. So I'm just saying, if it collided, increment this by 1. Okay, you could do some more complex logic here. You could call another function and say, well, if it collided in the same second, count that as 1 hit, right? Or in the same 2 seconds, count that as 1 hit. You know, you don't have to, like you can have 100 points the way that I'm doing it, and that's weird. Okay, so you could do something a little more sophisticated instead of just counting up how many times the pixel overlapped in the measured period. Okay, so that is everything. So, any questions about any of that? Sorry for being so boring and talking so much. Did not intend to do that. Nothing. What if I don't want the background to scroll? If you don't want the background to scroll, there are a couple things you could do. You could not call this right here. Okay. So I could just save this. Let's see. And then reload. Now the image is just static. Easy as that. Which means you could get rid of that function, the move background function. So you wouldn't have to just comment it out. You could delete this line and get rid of move background. You don't even need it. Cool, cool, cool. Taking functionality out? Maybe. Maybe. Depends. Is it possible to delete the bullet the second it hits the enemy ship? Sure is. Yeah. I'll leave that as a challenge to you. How can we make the enemy shoot? The same way that the player shoots. So you'd want to probably have you'd want to have some kind of condition that would cause the enemy to shoot, right? So either random or something else like that. So I have one bullet on the screen at a time. So you probably want to have maybe you only want the enemy to shoot, not the player. So that would be, you just change that around a little bit. And but if you, let's say you have an enemy and a player and they can both shoot each other, the enemy, you'd want to have another bullet. So when you create in game, you'd in some fashion want to have another bullet, a second bullet, not just. So you need to have, like, let enemy bullet equal new bullet, like this, something like that, right? Just, I mean, basically copy this. You could just copy this. You could use the same bullet. You should pick new images anyway for your stuff, but and that won't just do it. You'll have to go in and you'll have to alter how these things work, because bullet is really hard coded to begin its journey from the player, and it begins based on when the spacebar's hit, and that's all determined by those bullet functions. So you could just create a different, make it not bullet. You could make it an enemy bullet thing that's completely different, but sort of based on the same thing. Yeah, those are good questions. You should try those things, and then see how far you can get in those, and we can circle back on those next week. Then when I ask if you have questions, you don't say no. We can look at actual things. Can I make my game look like a classic space game from the 70s or 80s? As long as you have full copyright on the images you use, so don't steal somebody else's images. Okay, so if you draw your own images, or they are, you have, they're open source images, or whatever the copyright is okay on them. Just be aware of those things. But you absolutely can, yeah. I mean, in fact, like this stupid game that I made, like that isn't really a game, I'm sure is like some game from ancient times. So really the only thing that I would strongly urge you not to do is to just use some library that makes this a lot easier, because I'd really like you to know all the code that goes into this, because I don't think that any of the code that I'm using is above what you should understand. So if there is anything in there that doesn't make sense to you, we should talk more about that. But I think all of that should be pretty understandable. I'm not doing anything more sophisticated than random number generation and comparisons, like true false comparisons, and addition and subtraction, really. So there's no heavy math in this at all. And for really good games, there's a little bit of math. There's at least some like trig functions involved, probably. Any other questions at all? If there's nothing else, I'll at least wrap the video up. Anybody come up with anything at the last minute? 3, 2, 1. Stop.